friends, welcome to this video. In this video, let's do some fun and let's try to make a Fibonacci series program in MATLAB. I know for some of you it may be very easy and simple, but let's try to do it. I'll do it in both MATLAB script and then we will design a Simulink model also for this. Both are very simple and it won't take more than few minutes to complete that. So before we start, let's see what the Fibonacci series is all about. So I have opened this Wikipedia page. So I will not go in details, but in short, the series what it tells is the first and second number is fixed, which is f1 equal to 1, f2 equal to 1, and after that it's the sum of the first two numbers. So 1 1, then 1 plus 1 2 plus 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, and it goes on. And also it says often, especially in modern usage, the sequence is extended by one more initial term 0. So let's try to do this modern age. Let's do the modern Fibonacci series in our MATLAB program. Okay, so I will switch back to my MATLAB environment and let's start with the first. Let's do it in MATLAB script, a MATLAB function. So for that I will initialize a MATLAB function. I name it like my Fibonacci. I think I will need one output argument to give the series, and as an input argument also I will need one to know the limit. To what extent do I need? Like say for example I need for first 5 numbers, first 10 numbers, because I can't go to infinite numbers. It has to end somewhere. Although it's an infinite series, but it has to end somewhere in my program. And for timing I don't need this. I think it is a mistake, or I have to expand this. I delete this part. Yes, so I would quickly like to save this. So let me save this. And the name which I will give is the same name over here, my Fibonacci. I think the spelling is correct. We could have copied this also, but I assume it's correct and fine. So parse this uses might be written. Okay, so I think this is because this comma, and yeah. So now we start. So if our input argument is, say for example, so in MATLAB the index starts from 1, so we'll assume that minimum value of input argument should be 1. So if it's 0 or less than 0, so say for example my input argument, okay, I don't need 1 also because I just remove 1, is less than or equal to 0, then my output should be in fact an error, but I won't print an error. I will just return an empty output. Yeah, so this ends. But if my input argument is greater than 0, that's if it's equal to 1 and more, then we need to output the argument. But for 1 there's an exceptional case, because then we will have the output argument of only 1, and if you go back to the series then that value will be 0 if my output argument is 1. So if my input argument is equal to 1, then print my output argument as equal to 0, and argument return, I do an end. But if my input argument is 2 or more, so I think the 2 will also be an exceptional case, so we do again for 2 as well. So these all are the exceptional cases which I am writing on the top. So if it's equal to 2, then my output argument should be equal to, I think it should be 0 and 1, and then I return. Yes. Now if my output argument is greater than 2, then we have to of course go in loop, because we can't keep writing if else for n number of times. So we go for loop where we initialize I equal to till 2 we have done, so we have to start with 3 over here, and we go until the value of input argument, and then we print our output argument equal to. So in this case, what will be happen is we need to retain this in the first place, because whatever is there beforehand we need to retain it, and then we need to proceed this with further addition, like 1 comma I minus 2 plus 1 comma I minus 1. So I'm adding the last two part of this output argument. This one is for the selection of the row, since it's a vector array, so we are just taking the first row, and then the respective column is determined by the second argument of this bracket. And I think what a mistake we are doing over here is this part should be initialized, even either its input argument is 2 or even if it's greater than 2. This is a kind of initialization. So if my input argument is greater than 1, we have to always do this. So because if it's 3D also, we need this to be initialized before coming into this for loop. So for that reason, probably what I will do is I will just have it like this. I will always keep it like this, because the condition check for 2 will be automatically done in this for loop. Now I think that's solved. So this program should be fine. I think I can give a name equal to sign here. Okay, and this is because of the memory allocation. So we could have done the memory allocation by doing this output argument equal to zeros of this input argument. Probably I will write that command, but I won't implement in this video. So something we could have done is like zeros of 1 comma input argument, which will initialize, do my memory allocation here, but it becomes a little tricky. I knew it will give some error over here. Yeah, so it's better right now I will just leave it for the time being, and I will just assume that this it allocates my output argument at each and every iteration, which is fine. Now let's test our program, my Fibonacci, and let's test it for first a small value 5. 0 1 1 2 3. Let's go to the Explorer and see if everything. And yes, 0 1 1 2 3. This is the 5th number, and that's what is printing over here. We should also test it first for. Let me test for 0. It should return empty. Okay. If I just print 1, it's 0. If I just print 2, it's 0 and 1. If I just print 3, 0 1 1. Now let me go to some large numbers, say for example 15. So 0 1 1 2 3 5 8 13 21 24. Let me go back to my wiki. So 0 1 1 2 3 5 8 13 21. Yeah, that's precisely what the number I am getting over here. Good. So now we have done it in a MATLAB function. Now let's do the same thing in a Simulink as well. So now I'll quickly create a new Simulink model here. New Sibling model, and I just need a blank model and nothing more. So in this also we'll follow almost the same concept. We'll add two past values. So for that, first let me save this, and I will again name as my Fibonacci .slx, my Fibonacci underscore Simulink, to differentiate that it's a Simulink model and not a MATLAB script, of course. Now we will. So for Fibonacci, what we need is, first we need a sum block. So I just type sum over here, and we choose it from math operation. Plus and plus, yeah, we just need 2 plus, so it's fine. And what else we need is we need delay block. So we will have one delay. Length of delay is, I think, 1 time delay, because we'll need it 2 times. So we just do it is, I just make a copy out of it and I paste it. I will flip it because I will use it in the reverse direction, and so whatever my output is, it goes back to my input with a delay. So this can be connected, and sorry, this can be connected to plus here, and this can be connected to minus, and this second input will come from here because we are adding the f minus 1, the last and the second last, or better say this is the last and this is the second last value. And to see the value, we can probably add a scope, and number of ports is fine, and we just add this to, this is my final value. But be careful, we have to assign this initial conditions carefully. So for the first we can keep it 0, for the second one we have to keep it as 1, because this one has to come after a delay of 1 time slot. So this one has to come after delay of 1 time slot. And now if we start the simulation, let's better open the Simulink scope in parallel, and let's see what it happens. So we are doing it for 10 times, and if we see what it happened is it went till 7 as 0, and after that it went up to 10 to the power 10. Yeah, so if we see, it's going to a very large number, 10 to the power 10 times, and that's because I think because of the solver which we have chosen is variable step. So we should set it a fixed point solver, because we have to match the execution time of each and every cycle with the step which we are delaying with. Either we can change the delay to the respective, or better we change the solver to align with the delay time we have given here. So we change it to discrete or fixed point and discrete, and with a fixed step size of 1, yes, and we click OK. Now I think we should get the result which we are expecting. So I change it to 5 as well, and I do it. So yeah, so my value is 1 for first time stem, then second is also 1, then 2, then 3, 5 and 8. Yeah, so that's almost coinciding. So we need okay, so it's more of a first time series and not for the second one. But if you want the result something similar to second, what we can do is we can just put an additional delay block over here, and it should work fine. So let's try that very quickly. Okay, so I just copy paste this one, paste, and I flip it and I move it back here. I check the initial value, which should be 0. That's fine. So now I think this the whole of this will get delayed by 1, and this will first part will be 0, and then it will start from 1. So let's see that. Yeah, so 0, then 1, then 1, then 2, then 3, and then 5. Let's increase this time stamp to a larger number, say for example 15, to see what it happens. And if we increase it to 15, it goes up to 0, 0, 1, 2, 3, or this 15 becomes too much, above 600. So let's make it a little more realistic and 10, which we can probably visualize. And okay, so I think the first one is, this is 0, then this is 1, second is also 1, then this is 2, then this is 3, then this is 5, 8, 13, 21, this is I think 34, and after 34 is I think something around 58 or something, which you can verify here, or 55 here. So yeah, that's all. It was so simple. It was as simple as this to design a. What we can also do very quickly is, in this video we can verify by running our MATLAB function in Simulink using this MATLAB function block, which is I think somewhere around MATLAB function block. And so we'll call our MATLAB function from this particular MATLAB function block and see the output in the scope. Let's see if this holds true. So number of argument 1 is fine, and for input I will give a constant value of, say for example, for the first time let me give 5, and this should be fine. And if I double click to give the MATLAB function, it goes here. Okay, so I just either I can copy paste the complete code, or I can just call it Control C. I call it like y equal to Control V of u. So this calls my Fibonacci series. So let's see what it happens when we run this program. I'll open this second scope as well over here so that we can see the results in parallel. And okay, so there is some. So the error over here is that data y, which is the output, is a variable size because we are changing the size in our code here. If we go back to our code, so I think we'll have to tweak this code a little bit to make it work with the MATLAB function. So let's do that. So rather than calling this function from there, I will just copy paste this part, Control C, and I'll just do it for timing. And if my u is less than equal to 0, or rather than that, what we can do over, so we can do something like u and change it to u. But rather than that, I think this same code we can't use because the concept in this MATLAB function block will be a little different, because it doesn't take the number of iterations from this any input, but it takes from this time what we enter here. So in fact we don't need this input value here, and for that we don't need this u as well over here. So I think we'll have to rewrite our function. I was assuming that it will be very simple and easy and straightforward, but it is not. So let's try out. So what we will have to do over here is just like have two persistent variables. I hope you know the concept of persistent variable. If not, just refer to the document. So we'll have persistent u1 and persistent u2. So if you are really eager, I can just do a doc persistent. So this is the documentation, and basically we have to follow. You can just refer to this example. We have to just define a persistent variable and use this concept in our MATLAB script. So I go back to my MATLAB script where I define two persistent variable u1 and u2, and I do if is empty u1, then define my u1. So u1 will be my first initial value. So say for example I go back to my series. If I'm starting from here, so u1 will be my 1 and u2 will be my 0. So I take it from this side, from right to left. So I go back, u1 equal to 1, and similarly I do for the other one, is empty, and u2 equal to 0 as I explained earlier. Now once done, my output y will be nothing but it will be u1 plus u2. So in each time iteration we will have to do this. And so if it's the moment we remove u from here, it will be removed from the MATLAB function block also. Y will be u1 and u2, and we have to update the u1 and u2 also. So u1 will be equal to y, and but before I update u1, I will have to update u2 to u1. So this goes in a cycle like this. Yes. So I think this code of mine should work. Everything looks good. I go to here, I play my, yes, so everything is completed without any error. So this is my scope 1 and this is my scope 2. Yeah, so both of them have the same output if you see. Bingo. So yep. So we can just play around with some other value and see if both of them give the same value, and they both give the same value. It starts from like 1, then 2, then 3, then 5, 8. Okay, one thing you might have noticed that this is one step ahead of it. That's the same problem. This a kind of delay block, we may have to add it here to delay it by one more step. So that's why when it is 1, it has already reached to the second level of 2. So we may delay it by a delay block of 1, and that should be fine is what my guess is. Let's see. we just put it here, paste, and simulate it again. Yes, so it's 1, 2, 3, 5 and 8. Perfectly fine. Okay guys, thanks for watching my video, and please do post any comment if you have any questions, or please subscribe to my channel to get more videos on MATLAB, Simulink and similar programming language. Thanks a lot and have a nice day. Bye.